Alrighty, so let's welcome back, everybody. Let's begin review session part 2. So glad for those who were able to make it. I'm glad, and we can start with whatever questions you may have. For those of you who are here. So anything at all, guys, anything at all.
Professor?
Yes, hi.
So I was a bit confused on one of the evaluating limits, right? I'm gonna just read the problem off to you because I have it written down. I don't have the
Okay,
actual thing in front of me, but it's limit t to the 100.
hold on. So this is evaluating limits, right?
Yeah,
So this is the limit as t goes to what?
to infinity,
To infinity, yes.
and then so it's t minus t, and then radical t.
T minus radical t?
No, t minus t, then radical t.
Okay. T minus t radical t
Yeah, over
all over
2t
2t,
to the raised to the power of 2.
3 halves
Yeah, plus 3t
plus 3t.
minus 5. Now, part of the reason why I was confused is because, I kind of thought, I don't know. Can you just go through it because I don't think we learned the power rule and stuff like this, so it kind of threw me off when I saw the 3/2. I was kind of thinking maybe I have to set up
We've
that
done it.
power formula, do that power thing,
No,
but
no, this is something that we've discussed in terms of rewriting exponents. So look, t times rad t, I can rewrite rad t. I think we talked about this yesterday. This is t times t to the 1/2 power, isn't it?
yes.
So then when you just have a variable by itself, there's really a one that's being raised to it. So if we apply the rules of laws of exponents, if you multiply two bases that are the same, then the exponents are added, so you get t to the 3 halves.
Uh,
So in reality, this thing here is really just t to the 3 halves, which also appears here, which is good because how do we take care of limits at infinity? This is a limit where the variable is going to infinity. So this would be t minus t to the 3 halves all over 2t to the 3 halves plus 3t minus 5. Now, how do we take care of this? Remember, we have to always look at,
you have
so
to
find,
multiply by the highest.
yeah, find the term with
The
highest
highest
exponent,
exponent.
which happens to be
3/2.
3 over 2. I see both of them. So once I find that, then the second thing I do is I divide every term. Divide every term
By 1/x to the 3
by
3 seconds.
t raised to the 3 halves, which is the highest exponent. So that's what I'm going to do. So then this becomes, and I only do this, so this is only applicable
To the infinity.
yeah,
Okay.
for limits at infinity. If it's a limit at a particular value, then we're doing something completely different. We're going to be plugging in, or we're going to be factoring and canceling and then plugging in. Okay. Whereas in this case, we want to first figure out what's the highest exponent. And then what we're going to do is we're going to continue with this limit notation here. And I'm going to divide everything by t to the 3 halves because that happens to be the highest exponent. And then I get 2t to the 3 halves divided by t to the 3 halves plus 3t over t to the 3 halves minus 5 over t to the 3 halves. And then what happens is there's a lot of cancellation involved, right? There's a cancellation here. These are the same. So I'm left with 1 over
So
1, which is 1.
it's gonna be -1/2. So is that gonna be the final answer?
Yes, so that was yes. That eventually that's correct. So let me just fill in the details really quick. So then I get 1 over. So 1 minus 3 halves is negative a half. So this will be square root of t minus 1 all over. This becomes 2 plus 3 over the square root of t minus 5 over t to the 3 halves. But what happens with all of these fractions here,
They approach 0.
they approach 0 as t gets infinitely large. So that's why
Mhm.
we just like put little arrows here, because we know what's going to happen if t gets large, arbitrarily large. And so then what's left is the limit as t goes to negative infinity of -1/2, which is just -1/2, because there is no t expression after you cancel everything out. So
Mm.
the limit is indeed -1/2.
Okay. Once again, I made the same mistake. I looked at it and I was like, well, this is the first test, so I was like, there's no way he wants us to do the power rule, but the power rule is for anything.
Yeah,
I keep forgetting. I keep
don't
messing it up.
confuse. Yeah, don't confuse evaluating limits with derivatives. Don't confuse that. We aren't evaluating limits. I mean, we aren't differentiating at all at this moment. We're just evaluating the limit. So this
Yeah,
is
and the
this is
power rule.
prior to derivatives.
Okay. Thank you so much, Professor.
No problem. Great question though. Great question. Anything else, guys? Any other questions you may have? This is the time. So we talked about evaluating limits. Is there any other topic, any other question from anything, review sheet, exam?
Yeah, Professor.
Yeah.
Well, this is well. You don't really have to. Can you hear me properly?
Yes.
Yeah, my mom just dropped my laptop, so it's been really funky. Hold on. So it's I know how to do marginal function. It's just that I just want a quick, like, just a rundown of like everything. Do you know which lecture that was, and like
I mean,
for
that's,
marginal function, or can you quickly just like give us a quick little rundown?
I think review sheet number 2 has all about marginal
All right, so I'll try to go back and refer
function.
to your lecture. You probably did it in the like lecture or something. I don't know. I'll probably go check. I don't want you to
Yeah.
do the same like problems twice and stuff.
Yeah. Yeah, the lecture, let me just look at, I think we did it in second derivative test. No, test. I think we did it earlier. No, this is probably 16. Yeah, so if you look at lecture number 16, marginal functions
All
in
right, lecture
economics. So
number 16.
16 and yeah, 16 is the one.
All right,
17 is
thank you.
yeah. Hmm.
All right. Ready for another one.
For what?
For second derivative test relative maxima and minima. Question number 3. Sorry.
On the review sheet?
Yeah.
Okay, so let's look at the review sheet number 3, right?
No, two. Sorry.
Oh, review sheet number 2, and then
Sheet number 2, and then it's 2.5 2.
2.5 number 2.
Yeah.
Okay, 2.5 number 2. This is review sheet number 2. Section 2.5, number 2. So I want to find I want to use the second derivative test to find the relative extrema. So first I'm given a function, f of x is what? 2x cubed plus 3x squared minus 12x minus 4. So first I have to do is find the first derivative, which becomes what? 6x squared plus 6x minus 12. Then I set it equal to 0 and I solve for the equation and solve the quadratic equation here. And I can factor out as 6. So this becomes x squared plus 6x, pardon me, it's not just x, minus 2. equals 0. And so then the question becomes, what two numbers can I multiply to -2 that gives me +1? So can I factor this? The answer is yes. This is a +2, this is a -1, and then I get x equals 1 and I get x equals -2. So these are my, what are these?
Critical numbers.
These are my critical numbers because I just set the derivative equal to 0 and I solved it. So then whatever I get from the solution is known as my critical numbers. So these are the numbers where my derivative is 0, meaning that my slope of the tangent line is 0, which indicates that that line is horizontal, which indicates that it may be a max or a min. So then how do I
Wait,
determine?
Professor, can you repeat that again? I missed that part. You went a little fast. You said these are your critical numbers, and then you explained
Yeah,
why.
okay. So then what are the critical numbers, right? They're the x values that make my derivative equal to 0.
0 or undefined.
Huh?
Don't they make it 0 or undefined? I was answering your question.
Correct, but these specific ones, -2 and 1, are specifically making it equal to 0 because we
Yes.
just solved it, finding it by setting it equal to 0. So because these x values are the x values that make my derivative 0, that indicates that the slope at those points is 0, but the slope of what? The slope of the tangent line. And so that means that if my slope of the tangent line is 0, that indicates that the tangent line itself are horizontal lines. And the only occurrence of horizontal lines are when we have a max or a min. That's why we care about them. That's why they're called critical numbers. But now we want to figure out what these x values, what kind of extrema are they indicating? Are they a max or a min? So that's why we have to use a second derivative. So the second derivative will tell us the concavity of the function at those x values. So the concavity will indicate whether or not I have a max or a min. So then second derivative is just taking the derivative of the first derivative, which becomes what? 12x plus 6.
Plus 6.
So see, but the derivatives of this function is pretty straightforward. And now all I have to do is test what happens at -2, figure that out, and what happens at the second derivative when x equals 1. So when I plug them in, I get what? -12 times -2 plus 6, which is -24 plus 6, which equals -18, which means that I have a negative derivative at x equals -2,
Max.
indicating what?
You have a local max.
It's concave down. And
Yeah.
if it's concave down, I'm gonna have something like this, right? So there's
Yeah.
gonna be
Local max.
a max, exactly. So local max at x equals -2. And then I want to figure out the same thing for the second derivative at -1. No, pardon me, at +1. So this becomes what? 12 times 1 plus 6, which is 18, which is bigger than 0, which indicates that what? This is concave up. If it's concave up, then I'm going to have a local min at x equals 1. And then what do I want? I want to find the extrema, right? So not only do I want the x values, I want the corresponding y values. So all I've indicated so far was that I have a local max at x equals -2 and I have a local min at x equals 1. I want to find a specific coordinate, the coordinates. So now to find the coordinates, so to find coordinates, I need to plug in the x values into the original function, of course. So then if I want to find f of -2, right, I have to plug in to my original function, which is 2 times -2 cubed plus 3 times -2 squared minus 12 times -2 minus 4. This becomes 2 times -8 plus 3 times 4 plus 24 minus 4. -16 plus 12 plus 24 minus 4, bless you. And I get, what do I get? This here, I can make this a 36, subtract this by 4, and I get a 32, subtract this by 16, and I get +16. So then what's going to be the coordinates? The coordinates for the local max, the coordinates are -2 comma 16. So that's the first one. And then the second one So sorry, this is, let me just be more clear. Find coordinates of relative extrema. So this becomes f of what? 1, and I do the same thing. 2 times 1 cubed plus 3 times 1 squared minus 12 times 1 minus 4. So I'm really just going to be adding these numbers. 2 plus 3 subtracts it, 12 minus 4, and I get what? 5 minus 16, which is negative 11. So then the coordinates of the local minimum is 1 comma negative 11. Make sense? So that's how you use the second derivative test to indicate whether or not the critical numbers have a local maximum or local minimum at those points. So if it's a negative value associated with the critical number for the second derivative, then it's concave down, which indicates a maximum. If the result of plugging in the critical number into the second derivative gives you a positive number, then that indicates concave up, concavity that's upward, and which indicates that the critical number has a local minimum at that point. So that's really what the second derivative test tells me. Yes.
Okay, I got a little lost at 16 plus 12 plus 24 minus 4 equals 16, right?
Yeah.
Isn't the 16 negative? So 16 is negative,
Mm-hmm.
and then the 12 plus 24 is 32. I mean,
36.
yeah, 36, yeah. Then you minus 4 from 36, you get 32, and then negative 16 plus 32, shouldn't that be positive 16?
Yeah, it is.
You put negative 16.
Six,
Oh, at the bottom. I'm looking at the bottom. That's why I was like, what's going on?
yeah,
Okay, thank
yeah,
you.
yeah, yeah, yeah. The computation here is like the least of, well, it should be the least of your worries, right? Because you can just
No. I just thought that I had gotten the answer wrong because
no,
I thought that was your final answer because it
no,
was
no,
the
no.
lowest.
What I was saying, what I was doing was I was taking negative 16 and putting it underneath 32, subtracting that. Pardon me. So
Yes, I see that now.
I should get this at 16. So that's what I'm really saying.
All right, I get you.
So there's this neg 16, negative 16 the whole time, and then I just decided to like put it underneath. So yeah, that's just like scratch work that I just did. Okay, so is that good, Arnab?
Yeah, you're the best.
Okay, I'm glad.
Wait, another quick question. Are you gonna upload the grades before December 20th?
Yeah, I plan to.
Okay, good. Because then I'll know what my grade is. Then I could see your NC. Because that's like the time. Yeah.
Oh yeah, that's the deadline. Yeah, I would. I'm definitely gonna attempt to have everything as quickly as possible. I'm not gonna leave it all the way. No,
Oh,
no way.
that's really cool. Like,
When
Yeah,
is the deadline?
I
what's
don't.
up? Oh, it's December 20th. They had a council of meetings, and the president decided like for C and NC, which
Oh,
is
really?
like credit or no credit, and your GPA isn't gonna get affected.
Wow. Yeah,
Yeah.
I think that's a good option, I guess, for some. Uh,
For me, let me stop. Thank you
What
so
did you
much,
say?
Professor.
Hold
I
on,
appreciate it.
I can barely hear.
I'll text you, bro. I'll text you.
Yeah, put in the group chat.
okay. He, you said we can do absolute max and min, so that's gonna be from review sheet number 3, right? Is that correct? Absolute max and min. Question number 3. Is that what you said? Yes. Okay. So let's look at review sheet number 3. And we're gonna look at the first section on absolute max and min. So so this is the first section on abs, max, and min. And we're gonna do number 3. So number 3, we don't have any we don't have any interval, and that's because the implication is that we should know what the graph looks like. So if I were to graph this, do you guys know what this is the graph of? So normally our g of t, right? We can consider this as the y value. So just bear with me. Bear with me. Yes, that's right. It's a semicircle. If I square both sides, right? If I were to square both sides, I would get y squared equals 25 minus t squared. And then if I add it, I get t squared plus y squared equals 25. Normally we would have t as x. So just think about x squared plus y squared equals 25. And this is the equation of a circle. This is the equation of a circle. But when we solve for y, right? If I were to retrace my steps and I were to solve for y, the square root would indicate that I have a plus or minus. I'm going to get a plus or minus square root. But because I have just a regular square root, I have a plus. What that indicates, it's the graph of the upper half. This is the upper half of a circle whose radius equals 5 and whose center is 0, 0. So if I were to graph this, and if you were to plug this in your calculator just to give you an idea of what it looks like, it's going to be this. This is the graph of g of t square root of 25 minus t squared. So just by looking at the graph, we would already know what the maximum and min is. This is going to be my max. And the endpoint here, these will be my minimum, right? Absolute max. This is the absolute max. This would be the absolute min, right? So the graph would be useful to know what the endpoints are. So my interval, so notice my interval is implied to be -5 to 5. But we already know what happens at -5 and 5. We already know that the absolute minimum by graph, the absolute minimum is when x equals -5 or x equals 5. So if I were to plug it into g, right? Sorry, this should be not x, but t. So if I were to plug in -5 into the square root of 25 minus -5 squared, I would get 0 because -5 squared is positive 25. 25 minus 25 is 0. And similarly, I would get the same thing if I were to plug in 25 minus +5 squared. I also get 0. So 0 is my absolute minimum value. So this is my absolute min value. The values are also known as the y value. So when we say the value, we're really talking about the y value. Now by the graph, I'm already good. It's absolute, the max is 5. Let's say I didn't know that. Let's say I want to find the derivative. So I would have to plug in find the derivative first, right? That's usually the way we find the max or min. We look at the derivative. So then I would get what? I would get 1/2 25 minus x squared to the -1/2 multiplied by -2x. And then what would I say? This would be -x over the square root of 25 minus x squared. And I would set that equal to 0, right? Or I would say what? I would say 25 minus x squared equals 0. So this is so what I just did here was the way to find the absolute max or min by sidestepping calculus.
Mm-hmm.
And this is the way we would normally do it if we just went through the calc steps, right? We would find the first derivative, set it equal to 0, or find when my derivative is 0. And then don't you see that I get exactly the values that I found originally? Don't you see that in order for this to equal 0, then this would be 25 minus x or 25 plus x? Sorry, not 25. This is difference of perfect squares. 5 minus x, 5 plus x equals 0, which indicates that 5 equals x or x equals 5. And that 5 equals -x, or in other words, x is equal to -5. Didn't we say this already, or didn't we already know that this was going to happen?
Mm-hmm.
And then how is this derivative, how is this fraction equal to 0? The only way a fraction is equal to 0 is if my numerator is equal to 0, which indicates that negative x is equal to 0, or in other words, x is equal to 0. So I have my values. I have them. I have my x values that may have a maximum or a min. But I already understand by the graph that these are my endpoints, actually. These are the endpoints. And I already have established that they are the absolute minimum. Now, just to make sure that this is going to be a max, right? What do I do? I have to plug in to my original function, g of 0, which is what? 25 minus 0 squared, which is square root of 25, which is 5. And 5 is bigger than whatever happens when I plug in -5, which I did already here, right? I already plugged it in and I got 0. So 5, the y value, is bigger than 0. So this indicates that this is going to be the absolute max. This is the absolute maximum value. Obviously, just by looking at the graph, I get the maximum y value is 5 and the minimum y values are 0. So that's how we do number 3, absolute max and min. Any questions about this? Do you have any comments about this?
Just for like an FYI, the first way you did it, it's not necessity to know that method, right? Because to be honest, I didn't know that method. I knew the second method.
Yeah,
you did,
yeah.
but I didn't know the first one.
Yeah, the whole derivative part, right? So I guess you can say from this point on, right? Before this dash, this line here, above it, it's all non-calculus. It's just based upon the graph.
Yeah, that's just knowledge.
Here is the calc portion of it. This is where you take the derivative, set it equal to 0, find the points that make it 0, find the points that make it undefined, and then you plug it in to figure out which one's the biggest, which one's the smallest, and that's how you find absolute max and min. But you always want to, figure out ways to understand your problem, different ways, not just one way. Don't be just bogged down by one way of doing things. You have to always think about an alternative way. Okay, and then Coco says, let's do one on number 9 on the same section. So let's see how this is going to work out. So number 9, same section here, absolute max and min. This is f of s is equal to s square root of 1 minus s squared, and I have a defined interval, as most of them will have, right? So what's the first thing I have to do? I have to figure out first the critical numbers. And the critical numbers here would be what? I would have to first find the derivative. The derivative here. Let me just rewrite this as 1 minus s squared to the 1/2 power. So when I take the derivative, what do? I apply the
chain rule.
the product rule. So I
yeah.
first take the derivative with respect to s, right? Sandra, can you mute yourself real quick because I hear everything
in my background? Sorry.
Yeah, it's okay. So then I take the derivative of the first with respect to s and becomes 1 times 1 minus s squared to the 1/2 power, and I'm going to add it by, leave the first alone, take the derivative of the second function, and I get 1/2 1 minus s squared to the negative 1/2 multiplied by negative 2s. Okay? And then this will be equal to what? The square root of 1 minus s squared, and this becomes minus s squared divided by the square root of 1 minus s squared. Now you guys see how I did that? The plus here with the minus, I multiply this with this. This is a whole multiplication, so the negative comes up. The 2 and the 2 here, this is in the numerator, this is in the denominator. They're going to cancel out again by cancellation. Then the s here with the s is s squared. And then this whole thing here, this negative exponent, is a fractional exponent, and it's negative. So if I were to take this whole thing and place it in the denominator, I get 1 minus s squared raised to the 1/2 power, which is the square root of 1 minus s squared. And then I'm going to set this equal to 0. I'm going to set it equal to 0. And now I have to solve this. Now to solve this, what's going to happen is I'm going to move this piece here. I'm going to move it to the opposite side of the equation by adding it, right? I'm going to add by over s squared over 1 minus s squared on both sides. Now, why am I going to do that? So these cancel here. And then why do I do that? Is because now I'm left with the square root of 1 minus s squared equals s squared over the square root of 1 minus s squared. And then once I have that, I can multiply both sides by the square root of 1 minus s squared times the square root of 1 minus s squared, so that I could get rid of these square roots underneath. So these square roots here cancel, and then square root of 1 minus s squared times the same thing itself, the square root of 1 minus x squared, gives me 1 minus s squared. The square roots, in a way, they cancel each other out. In a way, you can think of it that way. And then this equals s squared. And then I can solve for s. So then I add s squared on both sides, and I get 1 equals 2s squared. So that means that if I divide by 2, I get that s squared equals 1/2 power, 1/2. And then I take the square root on both sides, and I get that s is equal to plus or minus 1/2. So either plus 1/2 or minus 1/2. But I'm on the interval, well, I am on the interval -1 to 1. So I have to figure out what happens at -1/2, what happens at positive 1/2. So these are my critical numbers because they make my denominator equal, they make my derivative equal to 0. So these are my critical numbers. So now I have to check what happens at the endpoints and what happens in the critical numbers. What happens when I plug it into the original function? So then I have to check values of at endpoints and critical numbers. So at the endpoints, I only have 2 endpoints. So x equals 1 is one of them, x equals -1 is one of them. So what happens when sorry, not x, s. So my variable is s. So these are my endpoints. So then I plug in 1 or I plug in -1. So when I plug in 1, I get 1 square root of 1 minus 1 squared, right? And this becomes 1 times the square root of 1 minus 1, which is 1 times the square root of 0, which is just 0. And if I do the same thing here, what happens? I get 1 minus -1 squared, which is the same thing as above, 1 minus 1, which is 1 times the square root of 0, which is 0. So I got 0. And then what happens in my critical numbers? So s equals 1/2 and s equals -1/2. So f of 1/2 is going to be 1/2 square root of 1 minus 1/2 squared. This is 1/2 square root of 1 minus 1/4, which is 1/2 times square root of 3/4, which is 1/2 times square root of 3 over 2, which is rad 3 over 4, which is clearly bigger than 0. And then this becomes f of -1/2, which is -1/2, the square root of 1 minus -1/2 squared, which is -1/2 square root of 1 minus 1/4, which is -1/2 square root of 3/4, which is -1/2 times square root of 3 over 2, which is negative rad 3 over 4. So what is the biggest? Rad 3 over 4. So that's my max. So this is my absolute max value. And then what is negative rad 3 over 4? That's going to be absolute min value. And I think that's it, right? So any questions about the max and min?
No. Professor,
Yes.
can we go over on exam 2 the question about marginal functions?
Yes. So exam number 2, and then we're gonna do compound interest. So let's look at exam number 2. So I have the solutions. I have the solutions there. Have you looked at it?
For the exam 2, it wasn't. I
Yeah.
didn't.
Yeah, there's solution. I have exam number 2. I have both 1 and 2. I put 1 recently, but 2 is on there. So if you want to check that out, and then if you have any questions on it, you can let me know. But if you check Google Classroom, I have all the solutions for
Okay, so I'll just use that. Thank you.
yeah, no problem. Okay. And then Coco, compound interest.
Well,
So if you look at the compound interest on review sheet number 3, and you want to do number 3. Okay, so number 3, right? So it says, how long will it take an investment of 10,000 to grow to 15,000 if the investment earns interest at the rate of 6% per year, compounded quarterly? Okay, so this is a straightforward compound interest problem, which is AP1 plus R over N NT, right? Something that you've probably seen before. And so we all know the values for all the variables except for one, which would be time. So we don't know what time is because we're trying to figure out how long it takes for the 10,000 to grow to the 15,000. So then the principal amount would be 10,000 because that's what we initially start with. The accumulated amount would be 15,000 because that's what we end with. R is 6%, which would be represented as 0.06. N equals 4 because we're talking about a quarterly compounding of the interest. And so then now we're going to use the formula. So when I plug everything in, I get 15,000 equals 10,000. 1 plus 0.06 over 4. This is 4t. So that's the setup. So once I have the setup, now I want to figure out what is t. What do? I divide by 10,000 on both sides. So then the 10,000s cancel here and the zeros here cancel, and I'm left with 1.5 on the left equals, and now just to make my life a little easier, I'm gonna do 0.06 and then divide that by 4, and then I'm gonna add that by 1. So I got 1.05. So this is 1.015 raised to the 4t. Now the problem again is that the t is a exponent, and I don't like having variables in the exponents if I'm trying to solve for them. So then the obvious thing to do would be to utilize logarithms. Either base is fine. You can do log base 10, log base 2, log base e. And I'm normally using e. So then I'm going to use e for this. This is ln of the natural log, ln of 1.5. This is an exponent, so I can place this in front by the power rule of log. So this is 4t times ln of 1.015. I'm still trying to figure out what t is, so I have to divide everything by 4 times ln of 1.015. And then what happens? Cancel, 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 cancel. And then this equals t. And then if I want to find the actual, so this would be my exact value. And if I want to find what it is, I would use ln of, let me just make that into a fraction first. So this would be ln of 1.5 over 4 multiplied by ln of 1.015, and I get approximately, so T is approximately 6.808 dot dot dot. So which is approximately, so in approximately, it would take approximately 6.8 years.
I did the same thing, but when I plugged into my calculator, it gave me 0.001509.203.
So, okay, so one thing about your calculator is that it doesn't know what it's doing. So maybe the way you plugged it into your calculator is incorrect. It doesn't understand what you meant to do. So maybe you did this. Did you do this instead? Is that what you got?
Yeah.
Yeah. Do you see why this is not correct? Even though you think in your head it is correct? Do you see how your calculator may um, actually, I would say your calculator does not misinterpret what you type. It just doesn't know your intention. Your intention is not to divide by 4 and then multiply by ln. Your intention is to do this. You see how crazy parentheses are? The moment I put that parentheses around the denominator, look what I get. I get a different value. So what I would do is suggest you to do the same for your calculator. Put the parentheses around the 4 and around the ln and watch you get the same answer. Did you try it?
I'm doing it right now.
So that's a very common mistake. You're not the only person to have done it. I think nearly everyone has done the same mistake because calculators, they don't understand what you mean to do. They just understand what you type in. So if you don't type in that extra set of parentheses, what's the calculator is going to look at it and say, okay, what you want me to do is divide. So what the calculator sees is if you write ln of 1.5 divided by 4 multiplied by ln of 1.015, the calculator, this is what the calculator sees. It sees this, quote unquote. It sees ln. So I'm going to first divide by ln over 4, and then I'm going to multiply it by ln of 1.015. Do you see how different this is compared to what you actually want?
Yes.
Yeah. So then because of that, you have to make sure you are specific in saying that, hey, I want the bottom to be a thing first. I want that to be a unit. 4, multiply that with ln, and take that, divide that by ln 1.5 divided by that expression. So that set of parentheses takes care of that. And so that's why you're getting it the wrong answer, even though you're doing every step correctly. Okay? So don't worry about that too much. Now you know. Now you know. So this is not the same as ln of 1.5 parentheses 4 times ln of 1.015. So this one here indicates this, and for this, it interprets it as ln of 1.5 divided by 4 times ln of 1.015. Okay,
I understand.
good. So now you shouldn't have any worries, right?
Yeah. I was panicking.
Good, good. So we're clearing
Professor,
up. Yes.
I'm doing what you said, right? But I'm getting 6.75
For what?
for when you did the ln times 1.5 over 4 ln 1.015.
You're getting a different answer, so you must have a different calculator. All like every
That,
calculator will calculate the same thing.
that's weird, right? Because well, okay, so
Are you typing it in exactly the way it's written?
yeah, but it's giving me 6.75. I don't know why.
6.75.
Yeah,
Hmm.
that's why I was
It
okay.
should be
Can you repeat exactly how to do it again? So it's gonna be
yeah, I have it written on the if you see on the screen, it's ln of 1.5, right?
ln.
And I don't know what kind of calculator do you have? What kind of calculator do you have?
TI 84 plus.
Yeah. So if you were to type this into the home screen, right, you would type it in exactly the way you have it right here. Every set of parentheses matters because calculators take things very literally. They don't interpret what you mean to do, right? So they only interpret or receive what you type in. That's all. So if you were to type it in exactly the way you have it like this, the way it's expressed here, you would get 6.808.
Okay.
There's no way around it because, yeah, calculators calculate the same way. Same thing.
Okay. I got it. Thank you so much, Professor.
No
I don't know
problem.
how I was getting 6.75.
Yeah, you might have put in like a 3 or some other numbers, right? Like it's very easy to type in different numbers.
Thank you.
Okay, wow, time flies. Like it's like just so fast. Anything else? So we've done compound interest, absolute max. Yeah, we've done evaluating limits. Anything else you want to see? View sheet, exams, homeworks, anything.
Can you go over all the steps with curve sketching?
All the steps to curve sketching. Wow, that's a lot of steps.
Yeah, are we gonna have a curve sketching problem?
Well, I would say be ready for that. So curve sketching, right?
Yes.
So the curve sketching, there's like I think around like 10 steps or something like that.
Yeah.
So the first few are just like the they are prior to calculus. So the first 4 or 5 steps, they don't require calculus. So the first thing is we have to figure out is determine the domain, right? I want to know the domain. So determine domain of function.
Mhm.
And then we have to find the x and y intercepts. So we care about the intercepts, x and y intercepts. So we care where those points are. And then we care about if there exists any asymptotes, vertical or horizontal asymptotes. And then along with that is the end behavior. So we want to figure out what happens at the ends. So these things are like non-calculus. They're like the non-calculus portion of it. And then after that is all the calc stuff that we've done, right? So the first thing is, of course, we want to figure out what? We want to figure out intervals of increasing and decreasing. But in order to do that, the key here, the key are the critical numbers. So we have to figure out the critical numbers. That's like the first important spec of our graphs, right? We have the intervals of increasing, decreasing, given by the critical numbers, right? We do the test points. So this is associated with this is the first derivative test. And the first derivative test gives us also the relative extrema. So these are the points, max or min. Right? We care about the max and the minimum. And then once we figured out the increasing, decreasing, that's the first derivative, relative max, then I want to find concavity. So I want to find the intervals of concavity.
Wait a second. Professor,
Yeah.
when we're finding the increasing and decreasing, right, we'll do the first derivative test.
Yes.
And to get the critical numbers, we'll set it equal to 0.
Yeah, the derivative will be set equal to 0 and you solve.
And then in order to find where it's increasing or decreasing, don't we have to like do a number line?
Yeah, you have to use the test points. So that's why you need the critical numbers, because without the critical numbers, what test
Okay. So, but we're gonna get the test points in 5, not 6, 7, right?
We're gonna find them in 5, right? Everything 5 is
Okay.
quite, yeah. You can subdivide 5 into finding critical numbers first, then you find the intervals of increasing, decreasing. Once you have that, you can number 5 immediately concludes or results in extrema, because if you know
Yes.
where you go up and down, you would know max. If you know that you go down and up, you know it's a min. So then you
Mhm.
get that immediately. You get the relative extrema immediately after finding increasing, decreasing. So there
And the number of test points you use is based on
is based on the
how many different x values you have. Like
it's
some.
dependent upon the intervals that are created when you find the critical numbers. So if I find, for example, if I find 2 critical numbers, right, then when I
Mhm.
put them on the number line, I have 3
Test points.
intervals. Yeah, I have 3 test points.
Okay. Thank you.
So yeah, in a way you could think of, if the number of critical numbers that I have, you add 1 to figure out how many test points you have. But just by looking at it on the on the number line, it's enough to. It's kind of like intuitive to figure that out.
Mhm.
The intervals of concavity, though, you need to use the second derivative for that.
Yeah.
So again, it's all kind of repetitive. You do the first derivative, set it equal to 0, find the critical numbers, put it on the number line, find where it goes up and goes down.
Yeah,
And
that's why I just wanted to outline the steps because
yeah, and then
it's just
second derivative, you take the second derivative, do the same thing, set it equal to 0, and then what you get might be what's called an inflection point, right? We want to find according to the inflection point. So then once we have that, these are also tied together. These are also tied together here. So the first derivative test, increasing, decreasing, relative max. Second derivative test, intervals of concavity, if it's concave up, concave down, which is also connected to the relative max extrema, but particularly it's connected with the inflection point. And once you have all of that, then you can plot, you can sketch graph using all these points. And that's it. So that's like all of the points for that.
so, Professor.
Mm-hmm.
If it's like an exponential function, it's like x squared minus x plus 3, something like that. The domain would be like all real numbers, right?
Yeah. Yes.
X and y intercept, you're just gonna
The x
you're gonna
the
you're gonna
y
you're gonna
intercept, you plug in 0 for x, and then you
yeah,
find the y
and
values.
then you solve for y just like how we would always do in algebra.
Yes, same thing. Yep.
Okay, and then vertical and horizontal asymptotes. How do you find those?
Well, for that example that you gave me, there is no horizontal asymptote nor vertical asymptotes. Polynomials don't have asymptotes. What have asymptotes are exponential functions, logarithmic functions, and rational functions.
Hmm.
So if you're given polynomials, you don't have to worry about asymptotes.
Okay, but just can you give me just like a quick example of if we are given a vertical horizontal asymptote, how would we find it? Just what the
So
format would be.
this would be a very simple example. Y equals 1 over x. That
Mm.
has the graph. If you were to graph this, this is what you would get.
Yeah, it approaches 0.
So obviously the asymptotes are going to be, one of them is going to be the vertical one, the vertical axis, and the horizontal would be the y-axis. And how do I figure those out? Well, to find horizontal asymptotes, what you do with horizontal asymptotes is you take the limit as x goes to positive infinity or negative infinity over my function. Whatever
Mm.
that value is, that's going to be my asymptote. So if you see, if I take the limit as x goes to infinity of 1 over x, what is it? Isn't it 0?
Yeah.
So the asymptote is y equals 0. And the vertical asymptotes are the x values that make my denominator equal to 0. So let me give you another example, right? So if I say, like, for example, y equals 1 over 2 minus x, for example, if I take the limit as x goes to infinity, I still get 0. So the horizontal asymptote would be y equals 0. But in this case, the vertical asymptote comes from the fact that 2 minus x equals 0, which means that x equals 2. That's a vertical asymptote for this problem, for this function.
Mhm.
Because the asymptotes are, remember, are imaginary lines where the function doesn't necessarily where the function approaches, it gets close to it. So if I were to graph this, I would get something like this, 2, right? So I get something like this. So those are the asymptotes. And again, vertical asymptotes occur when the denominator equals 0, solve for x. Horizontal asymptotes occur when you take the limit as you go to infinity. But you know how to do those things. So those aren't too difficult. It shouldn't be.
And then just end behavior.
And behavior is related to horizontal asymptotes.
Oh yeah.
It's related to taking the limit. It's exactly what it is. So if I take the
Oh.
limit, as I go to infinity or negative infinity, what happens to my functions at the ends? Well, they approach 0. Okay, then that's end behavior.
Okay, great.
These things here are just guidelines to give you a good understanding of what your function looks like. The meat and potatoes of this, if I were to give you a curve sketching problem, the meat and potatoes, I'm not so necessarily concerned with this portion rather than this portion here. And you can refer back to the exam number 2. I gave you a problem. Take that as an example of what you can get. Take exam number 2. I think it's the last problem, one of the last problems. I gave you a curve sketching problem.
Mhm.
Yeah. So look at that and then see, can I do a problem like this? Can I find it? I give you exactly. Number 6 is the last problem. Where is the function increasing and decreasing? What's the relative? I'm literally asking you for this.
Yeah.
I'm asking you all for this. So I know you want to know every little last detail, and that's how human nature, right? We want to know every single thing. And if one thing doesn't come out, then I'm gonna get this wrong, and then blah blah blah. I understand that.
Yeah.
But really, it's the bigger ideas that you should be able to have down pat, and it should be a calm assurance of it. It's like look at the more. This is the bigger picture here because we're dealing with calculus. This is pre-calc. This is more
Mhm.
calc stuff. And this is, if you can do this, then you don't have to really worry too much. And we've been doing this for the past 3-4 weeks. The same thing again and again and again and again and again. And again, I've outlined it also in the solutions. So if you look at the solutions for exam number 2, I show you how I do.
It looks like you only did the like you said 5 to 9.
Yeah, because
Okay.
that's all you really need for this particular problem. Because this is a polynomial. Polynomials are nice. I'm not gonna give you anything crazy. If I was a mean guy, I would give you rational functions and make your life complicated. But that doesn't. No, it's like, don't worry about the most weird case scenario. That's for another time. This is just,
Mhm.
do you guys know how to find intervals of increasing, decreasing? Do you guys know how to find relative extrema? Do you guys know how to find intervals of concavity? Do you guys know how to do that? If you guys do, then you should be all right. If you want to challenge yourself, then yeah, go do the hard.
When we're taking the test, we can just start on increasing and decreasing then, right? We don't necessarily even need to. Well, we do need the x and y intercepts so that we can plot. But other than that,
Right. That's what I do. And if you look at the part E, right, of question number 6 on exam number 2, it says sketch the graph and label the x and y intercepts, relative extrema, inflection points. I'm telling you, do this.
yeah.
And this is something that is the easier thing. Like, you guys should be able to do this without much of a problem. Should, question in quotes. Okay. Any last thing? Any last comments? If not, then I'll see you all tomorrow. Remember, it's at 8 a.m. So you have a few more minutes. No, it's
Oh,
part of it's 8:30. 8:30.
nice.
Yeah, it's 8:30 to 10:30.
You gonna be there for last minute questions or no?
Yeah, I could be there at 8 if you guys have any super last minute.
Well, I'm not going to bed tonight because I gotta make sure I do well. But
Well,
also I was gonna ask you, did you ever give any thought to when I was asking you before if you could let us go back and like get better grades on our homework?
The